Okay, so for the Calculus 1 class, let's talk about this topic referred to as logarithmic derivatives, okay? So we have a function like 4 to the x, and we want to take the derivative of this function, okay? We know that this is an exponential function, 3 parentheses. First parenthesis, log of the base. Second parenthesis, you copy it. Third parenthesis, the log of the exponent, okay, which is 1 in this case, right? So that's how we take the derivative of an exponential function. What about a function like this? Right, so this is the power rule, okay? So this one, the 3 comes in front, copy, new exponent is 2, right? Okay, so we have these 2 rules. What about a function like this? So if you say, oh, well, it's exponential, it has a variable exponent, okay? All right, so 3 parentheses. First one is log of the base, but there's no base, okay? X can't be a base, it's a variable. So what is the base? It depends on the x, right? Okay. If we wanted to do this kind of thing, okay, and bring this in front, and then take x, and then take x minus 1. Well, you know, this only works when this is a number, right? It doesn't work with exponential functions. It definitely does not work with this kind of function, okay? So this is a different kind of an animal, right? So we need a new derivative rule to take the derivative of this thing. But I told you there were only 9 rules, right? And I told you that those 9 rules would take you as far as you wanted to go with calculus. So what's up? Well, we don't need a new rule, okay? We're just going to take the logarithm of this thing first, and then we're going to take the derivative, okay? They call it a logarithmic derivative, but it's not like balsamic vinegar. You know, that's a type of vinegar, right? A logarithmic derivative is not a type of derivative, okay? It just is a poor term for the fact that we're going to take a log first, and then we're going to take the derivative. And the derivative has nothing to do with the log, or vice versa. Okay, so we have this. X to the x, we say it equals y. Okay, now we don't know what y is, but we're going to need that there. Now, we just take the natural log of both sides of this equation. Okay? And what natural logs do, of course, you know, they pull the exponent in front, right? So we get x log x equals log y. That's the logarithm part of this thing. Now this is purely just taking a logarithm, okay? No calculus whatsoever involved in this. Now we're going to take the derivative with respect to x. Notice that here we have a product rule, right? Okay, so product rule. And here we have a log. Let's start with the easy one first, right? ln, line, copy, y, derivative of y. Now, we're taking the derivative of this thing with respect to x, yes? So what's the derivative of y with respect to x? Well, this is an implicit derivative, right? So it's going to be dy dx, okay? We're not doing anything different than we would do if we just were given this and took the derivative of it, okay? Okay, so let's do our product rule, right? First thing goes in the first parenthesis, second thing goes in the second parenthesis over there, right? Now we need the derivative of log x. When over x, derivative of x is 1. So we end up with 1 plus log x equals dy dx over y, right? But what's y? Well, we had that x to the x equals y. That's what we started out with, okay? So y is actually x to the x. Now, if I want to take the derivative of both sides of this thing, right? Yeah, I'm going to end up with the derivative with respect to x of x to the x. And that's going to equal the derivative with respect to x of y So if I'm trying to take the derivative of this, it is precisely dy dx. So all I have to do is solve this for dy dx, and I'm done. So I get x to the x times, we can write this like this, log x plus 1 equals the derivative with respect to x of x dx, which is dy dx. So, logarithmic derivative is not a new type of derivative, okay? It's just the fact that we're taking a log first, and then we're just using our plain old 9 rules for derivatives to take the derivative of this expression, it's implicit, and get dy dx. These are interesting. If you have any questions about these, send me an email. You should be doing a bunch of these. You know, look through the book or wherever and get yourself 20 of these and do them. And if you run into something sticky, send me an email and I'll make a video about it.